What's up, YouTube? How's everybody out there doing? Not sure I'm actually connected. I see two viewers. Am I live? Okay, I guess I am okay because it's showing me that the stream actually ended. Okay, in any event, I guess it didn't. Hello, I'm Greg from Greg's Tutoring NYC. How's everybody doing? So for some of you, today was your first day of the New York State math tests for grade 3 through 8. Hopefully things went smoothly. With that segue, I'm going to be doing some of the hardest math problems. We're in grade 6, part 2. And I picked some of the problems from past New York State tests that most kids had problems with. They're the ones most kids got wrong, stuff like that. That doesn't mean they're the hardest from certain definitions, but other definitions it does. They're either tricky, they're deceptive, they're just complicated at some level. Sometimes it's not about the math; it's about your understanding and your fluidity and your numeracy and other things like that. All right. And again, we want to approach these not that they were taken from a standardized test. We just want to approach them mathematically from their own perspectives and so on. All right. So I'm just going to jump into this one pretty quickly so that we're not wasting time. I actually have a bad headache. I'm not sure I'm going to be able to last too long today. So let's see how it goes, and then we'll move forward from there. So we're up to this question from part 2. And by the way, there's a whole bunch of these still, so we're most likely going to do part 3. Today I'm going to try to shoot to go 45 minutes. Okay. And by the way, that means there's more of these coming. Okay. Just on this series alone, and I already have hundreds of hours and hundreds of videos already about various math and ELA topics. I like to focus on standardized tests and admissions exams, but we talk about other stuff as well. And so, hey, join the channel, have some fun, relax. Okay, get some popcorn and a pencil. All right, and for those of you catching this on the replay, welcome as well. And what you can do then is, as I come to each problem, pause the video, try to solve it yourself, and then see what I do. And a lot of these I'm going to try to give alternate ways to solve them when that's possible. I'm also going to give ways to solve them that are not necessarily mathematical. Some of these I want you guys to bump up your numeracy and fluidity games so that when you see certain things, they kind of leap out at you and they start making mathematical sense. These questions are oriented to roteness and memorization because they're from a standardized state test. But you should be able to apply other concepts to them that will kind of get an extra level of abstraction up over them so that you can basically solve any math problem for any reason. And we're trying to get you to be astute and understand what's happening mathematically, not just following rules robotically, but just trying to understand the math of the problem and reason it through. That's what problem solving is about. It's not about opening a playbook and saying, oh, I should do step 1, step 2, step 3, 4. Of course, those steps need to be there in a lot of cases, but there's other cases where you're going to use your mathematical prowess to actually solve these problems, all right? Okay, I see this few people in the lobby. Welcome, and hopefully everybody's doing well. Like I said, grab some popcorn and a pencil, and let's get cracking. All right, so the first problem we're going to do today is number 43, residence. So we're going to take this. Let me get my pencil set up. 1 second. Okay, so residents of a small city voted on whether to allow a developer to build a shopping center. So that's the end of that. Okay, I normally take these one sentence at a time, and within a sentence, one phrase at a time. All right, so there's a shopping mall. Big deal. The number of votes in favor of the shopping center was 4,400. So that's okay. So we're stop. The number of votes against the shopping center was 17,600. Okay. What percent of the voters were in favor of building the shopping center? Okay. So this is not a hard problem to understand. So I think from one sense of this, most of the kids reading this will understand it. But there's a little gotcha to it. Okay. So let me show you the problem first, which I'm sure most kids did. Most kids did 4,400 over 17,600. So what they did was they set up a ratio of those for versus those against, okay? And if it leaps out at you, and again, this deals with your mathematical prowess. Let's just do 44 over 176, okay? It should leap out at you that this is a quarter. This is 25%, okay? And if you follow some of what I told you the other day, this is a 6 here, by the way. Let me erase that and make it cleaner. Okay, double 44 is 88. And 88 plus 88 is 176. So what happens in a lot of standardized tests, and again, I don't want to make this about tests, but it's also about the problems your teacher gives you. Sometimes your teacher does give you problems that have weird answers like 1.23. But on a standardized test, often they're just trying to test, do you even understand what the concept is? Okay? So what often happens, a lot of standardized tests, there's no guarantee here, is that the numbers are written in such a way that they're in your favor. So let me go on a second sidebar. We're in a sidebar already. I'm going to the second bar. If I gave you something like 3/4 times 16/9 times 1/8, that's an 8, times 64 over 3, okay? The way to solve this problem is not to do 3 times 16 times 1 times 64 over whatever. It's to cancel stuff out. This was a 3. 3 goes into 3 once. 3 goes into 9 3 times. Okay, this was a 4. 4 goes into 4 once. 4 goes into 16 4 times. Okay? Okay, there's nothing to cancel after the 64. And we get 9 at the bottom. So we reduce this to 9 at the bottom, if I wrote my sloppiness right, to 64 times 4. So 64 times 4 is 128, times 2 is 256. So we're almost able to reduce this down to doing it in our heads. So use what you know in your math to give you the prowess you need. So in any event, to go backwards to this sidebar, most kids are actually going to get 25% as the answer. That's wrong. Can anybody see why that's wrong? Let me just make sure we're live here again. Yes, we are. Okay, it's wrong because it's comparing the number in favor against the number against. And the real way to solve this, and let me get rid of the stuff on the side here because there's not enough space. Let me get rid of all this for a second. Okay, the real way to solve this was not this. It's going to be those 4 over all of the voters. So this was for, I'm going to make that say all because over against. What we want is the 4 over the 4 plus the against. Okay? It has to be out of all the voters, not versus the other one. That wasn't what the question was. It says how many were in favor, right? If there were 2 voters and 1 was in favor, the answer isn't 1 over 1, and that's what this crossed out thing does. It makes it 1 over 1. If there were 2 voters and 1 was in favor, the answer would be a half. Okay? because all the voters is those for and those against. If one was for, then one is against, in the case if there was only 2 voters, right? So what you want to do in a lot of these cases, and we had an example yesterday where we reduced it down and we use simple numbers. Forget about the big ugly numbers that they use. Just reduce it down to something super simple, okay? And what I normally like to do with that little kind of tidbit of information is also I generally avoid using 0 and I generally avoid using 1, even though I just did. Because sometimes they become special cases that turn out to work out to be true, even though the generalization that you're trying to shoot for is false. So you can use 2, 3, 4, 5, 6, 7 like that. In a lot of cases, they work out really nicely. So again, this deals with your mathematical prowess again, your astutness. So what we're going to have is 4,400 over the 17,600 plus 4,400. Okay? So 17,600 plus 4,400 gives 22,000. Right? And you're going to have, just to show, you have 17,600 plus 4,400. Okay, we can tally it normal, or we could just say 17,000 plus 4,000 is 21,000, and 600 plus 400 is 1,000. So 21,000 plus 1,000 is 22,000, right? So this deals with your mathematical prowess again. So now we're going to get 22. We're going to get 4,400 over 22,000. Okay, these 2 zeros cancel those 2 zeros, so we get 44 over 220. Okay, so your mathematical prowess again should kind of ring your bell, especially you're getting a heads up by looking at the answer choices. Okay, you should know 44 over 220, it can't be 44 or 40%. You already know it can't be 25%, so the answer's got to be that. But if you also look at it here, if you do 40 times 5, that's 200. And 4 times 5 is 20. So this is equal to 1/5. Yeah, right? You should be. So again, if you try to just spend a second and look at the numbers and see what's going on there. Okay, so the formal proper way to do this is to actually do the division. So if you got 220 divided into 44, and you know that there's going to be decimal points here too then. Okay, so 220 into 4 can't do. 220 into 44 can't do. 220 into 440, what is that, guys? We bring up the decimal point because that goes there. We have 0, 0. 220 into 440 goes twice. And then there's nothing left over because 220 times 2 is 440. We subtract it, we get 0. And this just goes over here. What do we have here? We have 0.20, which is 20%, right? 0.20 is equal to 20 over 100, which is the same as 20%. Percent means divided by 100. So 20% literally means 20 divided by 100. And that's the answer we got over here. Okay? So there's a whole bunch of ways to double check this and use different mathematical ways to figure this out. All right? So the gotcha is that I'm sure the gotcha was that most students did the number for versus the number against. But it's the number for versus everybody's vote, not just those against. Okay, so this is a word problem. I already see this fractions. I see this mixed numbers. I get a feeling already that this is ugly and nasty. It may not be. It may not be. Let's process it and see where we might go with it. Maddie had a piece of ribbon that was 3.5 yards long. Okay, end of sentence. Okay, what did we learn here? This is a 3.5 yard long piece of ribbon. Whoopsie-doo, right? She uses this ribbon to make bows. Cool, so awesome. Each bow was made from a piece of ribbon that was 3/4 of a yard long. So there's a stop here. So at this point, you should be ready and almost prepared to know what the question probably was. Okay? They're probably going to ask, how many bows did she make? So if it's 3.5 yards long, and each bow used 3/4 of a yard, yeah? What we're probably looking at is 3.5 divided by 3/4, which turns out to be what they give us here in the next sentence. Okay? But think that through. At this point right here, you wait 1 second. At this point right here, that's what you should be thinking about. As you're reading this, you should stop here at that point and say, you know what? I wonder how many bows there are. Even if that's not even the question, that's something you should think. Because what you're doing is you're tapping yourself on the shoulder and you're forcing yourself to think mathematically and conceptually about what is actually going on in this problem. Why is it significant? Why is it important? Why the heck are they asking me this stupid question? Right? So process it. Take the time at every sentence and figure out what you learned. And as you're going along with each sentence, you're going to build up your knowledge. Maddie had a 3.5 yard piece of longer ribbon. Cool. She used the ribbon to make bows. Okay, cool. That means the combo of the two of the ones is that she used a 3.5 yard long piece of ribbon to make bows. When you tied the first three together, is that she used a 3.5 yard long ribbon to make 3/4 yard long bows. Right? You can do that. And you can ask yourself questions about stuff. Even at the first question, how many yards was it? It was 3.5. After the second question, what did she do with it? She made bows. After the third sentence, you might say, oh, well, how many bows was there? Okay, you don't really have to answer the question. You just necessarily need to think about it. But sometimes it's worth answering it. But sometimes that's actually going to be what the question is. Okay? So then it says, this situation can be represented by what I squared here. That 3.5 divided by 3/4 equals 4 2/3. You're going to ask yourself, what does 4 2/3 mean? What does that mean? It says this situation. What situation? Well, it's a situation where she made bows from a 3.5 yard long ribbon with 3/4 yard, where each bow was 3/4 yards. So this represents that. So wait, could 4 2/3 be the number of bows? Could that be what that is? It seems to me that it is. Okay? And you should stop right here again. Stop. Figure out where that equation is coming from and what it means. And by them using vague language like this situation, you gotta tell yourself, stop. What situation are they asking you to analyze and figure out here? Okay? You can't just zoom through this and go like, I don't know. Right? That's no good. Take it a sentence at a time. If you can't figure out the first sentence, then the second sentence has no meaning. If you can't figure out the first two sentences alone and in combo, then the third sentence has no meaning. If you can't figure out each of the first three sentences individually and then build them up to the three altogether, then nothing has meaning. You have to understand it. And as you're going along, make an understanding of what the numbers mean. What does 3.5 yards long apply to? What's it about? Why are they telling me something 3/4 of a yard long? What is 3/4 of a yard long? Okay? And then finally, when it comes to the fourth sentence, what situation are they talking about? They're talking about a situation where bows, 3/4 yard long bows, were made out of 3.5 yard long piece of ribbon. And does that equation actually reflect that? Because it may not. This equation might be talking about something else. So I think that it is talking about the number of bows. Okay? So finally, we're going to get to the question. Now that we ripped it apart, we analyzed it. Which statement best describes what the quotient 4 2/3 represents in the situation above? So a lot of standardized tests do this. We want to avoid the notion that we're actually trying to solve standardized test questions, but this is a reality of the question we're giving. In a lot of cases, you can ignore that word. In other words, which statement describes what the quotient means? And by the way, if you don't know what quotient is, this thing up here is the quotient. It means that there's a division there. The quotient is 4 2/3. Sorry, I pointed to the box, but it's actually the 4 2/3. Because we have a divisor in a I forget the term myself right now, but so what describes what 4 2/3 means? So I think we're trying to look for something that talks about the number of bows. Okay, so let's rip apart the answer choices now. And by the way, as much like when you have a reading comprehension problem, and this is math, by the way, but let's say you had to read a passage, and then they gave you questions maybe about the main idea. Okay, a lot of kids get really bent out of shape about reading the passage and understanding it. And don't get me wrong, that's important. But a lot of kids just focus on the reading comprehension of only the passage. But a student also needs to worry about comprehending what even the question is and also comprehending every single answer. They're just as important. So this is a classic scenario in the math that you're given a word problem, even though this is math. Your reading comprehension has to be high enough that you're processing what the math is even asking you to do. And you're able to do inferences and interpretations and so on with the answer choices here. Now, this is a question that's oriented that there is only one answer. So when they say which statement best describes, no. There's one answer here. There's one answer here. There's no best. Which statement only describes is what we're looking for. All right? So don't let your brain get skewed by the use of this word best. You can even cross it out on the test paper and then reread it. Which statement describes the quotient? Okay? Maddie had bows that were 4 2/3 yard long. Is that true? No, she had a ribbon that was, does this represent how long each bow was? No, sentence number 2 told us that each bow was made out of 3/4 yard long. In fact, let me erase that for a second and change the color of the pencil so that we're highlighting this. This sentence right here conflicts with choice number A. So A is no good. Okay? B, Maddie had 4 2/3 yards of ribbon left after making the bows. No, it's the total length of the ribbon divided by the amount of ribbon per bow. So that would give us 4 bows with 2/3 left. So from that perspective, there's something left, but it's 2/3 left, not 4 2/3. So B is no good there either. Okay? I can see some kids being confused about B, but it would be 2/3 of a yard was left, not 4 2/3. Okay? C, Maddie made 4 bows from the pieces of ribbon and had 2/3 left. Booyah, that's the one I'm talking about so far. Okay? So it's C. All right? So far. But is that what it's saying? Is that what it's saying? That she had 2/3 left? Maybe. Maddie had 4 bows from the piece of ribbon and had enough length to make 2/3 of a bow. Yeah. So if we look at the 4 2/3, if this represents the number of bows, then we can't say the 4 is the number of bows, but the 2/3 is yards? That's mixing units. So there's 4 full bows and 2/3 of a bow. Not 2/3 of a yard, but 2/3 of a bow. So that would be the second error here that some kids would make. Enough kids would say the answer C and just go to the next question. And that's why it's sometimes important to look at every answer choice. So C is wrong. and then D is actually the answer, okay? Right? If it's the number of bows, 2/3 also applies to the number of bows, not to the number of yards, okay? So be careful with that. So this kind of is a hard question. And a lot of kids got this one wrong. So there's a lot going on here. And by the way, this builds off a standard question. I think we had this one similar to this yesterday, and we even had one similar to this in the 5th grade. And there's probably one in the 4th. So this is a very standard pattern question where they're asking you to do something. Usually they're asking you to calculate the 4 2/3. In this case, they're telling you this is what it is. And what is this is going backwards. So normally we're mapping the English to the math. Now we're taking the math and we're mapping it back to the English. Okay, 45. This is a doozy of a question. Just an absolute doozy. So we're going to do our standard thing. We're not going to look at the words. We're going to look at the illustration first. So we have what looks like a triangle that's split into 4 other triangles. There's a dotted line here, breaking it into 4 triangles. The bigger triangles broken into 4 small triangles. I'm going to label them A, B, C, and D. So we're visually kind of representing that. We can see here that, and we're going to make a guess. I'm going to make a guess that the giant triangle, I'm going to draw that T, is probably an equilateral triangle. And I'm also going to make a guess that A, B, C, D are also equilateral triangles. But we don't know that for certain yet. We're going to have to see what it says. Okay? We also know that at least the length of D has one side that's 5. Okay? We also know that, what is this 4.33 here? Okay? It's telling us if we shift this over to here and we put it right there, it's telling us that the height of A, the height of triangle A is 4.33. Right? If we just take this line and shift it over, that's what we're getting out of that. All right? So there doesn't seem to be much else we can get out of this. Maybe they're combining B, C, and D, because if we combine B, C, and D, we get a trapezoid out of it, right? If we combine A, C, and B, we also get a trapezoid. And if we can combine A, C, and D, we get a trapezoid. Tilt your head over, guys. Or I don't want you to turn your laptops upside down or whatever you have, but in fact, some self-oriented. So depending on what you're doing is on a phone or not, you may have to turn your head no matter what. Okay? So we analyzed the figure, I think, as much as we can. We made some speculative conclusions. All we really know is that there's definitely a giant triangle. There's definitely 4 within it. The side of D is 5, and the height of A is 4.33. Okay? So now let's see what's going on. The figure below shows the net of a triangular pyramid. Okay, so if we drew, and my handwriting is horrible, so how can I do this best? So imagine a pyramid. That's what I just drew there. Just drew a pyramid. Where this line is in the front. So there's 3 sides. There's this side here, and then the bottom. Okay? And then there's a side in the back there. So what happens is, if I broke the seams here, I break this seam, I break this seam, and I break this seam, and I unfold it, I get this thing here. So the unfolding is called the net. Okay? This is interesting because this was on a New York test, but New York classrooms, this rarely gets discussed in the classroom of what a net is. Okay? And a triangular pyramid just means it's a pyramid based on triangles only. There's also pyramids where the base can be a square. So it might come out like that, okay? So this is one where this is one because basically C is the base. So you've imagined you could take this point here and fold it up to here, and this point here and fold it up to here, and this point here and fold it up to here. You're going to get a three-dimensional pyramid out of that. So that's what happens. Let me just back off of some of this so we get a cleaner screen. Okay. So the figure below shows the net of a triangular pyramid. Okay. The given height is rounded to the nearest hundredth. So they're talking about the 4.33 here. Okay. Since it's a triangular pyramid, that means all four of the pyramids are the same. Okay? All four of the pyramids are the same. So that means this will be 5. Okay? It means the height here is going to be 4.33. The height here is going to be 4.33. And this one's upside down, but the height here is also 4.33. Okay? It also means this is 5. That's 5. That's 5. That's 5. That's 5. That's 5. And that's 5. So we have 4 equilateral triangles stuck in the middle of here. Okay? Everybody good there still? Okay? And then it's telling us if they're equilateral. So this proves that they're all the 5s. What is the surface area of the pyramid in square centimeters? So the surface area is basically, imagine if you folded these up, if that was a piece of paper, and you fold them up, right? Since we opened them into the net, they're asking what is the area of the giant triangle? Because the surface area is the area of A plus the area of B plus the area of C plus the area of D. Right? A is two-dimensional. This is a two-dimensional triangle. So what we started out was the three-dimensional triangular pyramid. We unraveled it. We saw its net, which is now 2D. The 2D representation is the original illustration they gave us. Okay? So what they're asking is basically, what is the area of the triangle I called T? Right? So how do we do that? How do we do that? Okay, there's a couple of ways we can do this. The area of a triangle, any triangle, is 1/2 BH. Okay, do we know all that information? We do, because this is the base. So 5 plus 5 is going to be 10, right? So that's going to be equal to 1/2 times 10. Okay, and do we know the height? Yeah, we know the height because if this, I'm going to use a different color here. If this is 4.33, then this is also 4.33. So the height is 8.66. Okay, but the interesting thing here is we're going to take half of it. So we get the 4.33 back. And now we have 10 times 4.33, which is equal to 43.3. And we're done. The answer is B. All right? And if I erase everything here, let me do that real quick. because we did a lot of analysis here. So let's say you're seeing the problem straight up from the get-go. Come on, erase, erase, erase. Once you know that it's the net of a triangular pyramid, and once you know that all the triangles are equilateral, you should just bing, bang, boom. Okay, this whole height is 8.33. This whole length is 10. And that's it. You're done. That's all you need to know. Just those two lines. And it's 1/2 BH. That's it. You're done. There's no other clutter. So analysis is important. A lot of kids will speed read all this. Again, they're going to read the words. You're going to skip the illustration. No. Focus on the illustration. Understand why you're being given that illustration. Then go back to the words. Take it a sentence at a time and build up your knowledge. Just the same we did with the word problem. The one we just did before this. Build up your knowledge and figure that out. Let me just make sure we're still live. We are. How about we going? We're going only 36 minutes. My voice is kicking out and my head is actually killing me. I have chronic head pain, so I'll do the best I can. Okay, this is also a word problem. And if you look at the answer choices, they're all expressions. So they are not asking us to solve this numerically, although sometimes that's good to do. And what I mean by solve numerically, they're not asking us to get a value, because P minus 20 is symbolic. Okay? So Zelma buys P pounds of bananas for 40 cents per pound. Stop. Right? Do we understand that? Yeah, that's easy enough. She bought bananas at 40 cents a pound, and she bought P pounds of them. And you could experiment, right? If she bought 2 pounds, she spent 80 cents. If she bought 10 pounds, she spent $4. Okay? She pays the clerk with a $20 bill. So it's 40 cents, and this is $20. Okay? The clerk subtracts the total cost of the bananas from the $20 bill to determine the amount of change. Okay. So she buys P pounds of bananas at 40 cents each, 40 cents a pound each, pays her $20, and she gets change. Okay? So hopefully that means she didn't buy like 100 pounds of bananas, because then she probably has no money left. So we're not going to go through that nuance, because that's not what they're asking us here. So which expression represents the change, the amount of return, the money she gets? Okay? She would receive. So it's okay to go on your own sidebar and do an experiment. Right? So like I said, if she buys 10 pounds, then hasn't she paid $4? Right? So if she pays her $20 and she paid $4, isn't her change 16? Right? If you need to, do a second example. So let's say she buys 1 pound, right? Then doesn't she pay 40 cents? Right? And if she pays $20 minus 40 cents, doesn't she get $19 and 60 cents back? Okay? So it seems to me it's 20 minus whatever she paid. Okay? So let's see if we can find that. So this is the number of pounds minus 20? No, that's completely nothing like what I talked about. Okay? Okay, B. B is 20 minus something. Okay? So is that it? Because the problem is C is also 20 minus something. Okay? So let's leave B and C alone for a second and look at D. D says 40 cents a pound because P represents pounds. 40 cents a pound minus 20. No, that's backwards. Okay? So enough kids probably didn't know what to do. A second category of kids probably answered choice B. Choice B is wrong as well. Okay? And D is correct. C. And C is correct because it's $20 minus 0.4. That's 40 cents. Okay? This 40 here represents 4,000 cents, right? That means $40. $40, 0.00 is 4,000 cents. So that's no good. So the price per pound is 40 cents. Okay? If we use choice B, if we said minus 40p, then we would have had to convert to 20 into 2,000. Okay? If it was 2,000 minus 40p, that answer would be good too. So we need to convert both the currencies into the same units we're talking about, right? One is $20 and one is 40 cents. So they both have to be in dollars. 0.4 is 40 cents. 40 cents is $0.4. So now they're both dollars. 2,000 cents is $20. So that's converting dollars to cents. So that was our two choices. They didn't give us this choice. The only choice they gave us was C. So be careful with stuff like this. And again, this you could say, oh, they tricked us. No, this is about knowing your math. It's about knowing your math. Be attentive to details. Okay? All right, so we have a chart. We're going to look at the table first, the illustration. It's a chart with something in it. It's labeled, so this is informative. The title of something is information. The masses and corresponding weights. So there's two columns. It means there's a certain mass in kilograms with its corresponding weight. So those two go together in a pair. So that 20 corresponds to 196. 50 corresponds to 490. X corresponds to 1078. 130 corresponds to 1274. And 140 corresponds to 1372. Now, on certain charts and tables and histograms, there's stuff that leaps out at you, like you can add up things. There's nothing really here. I don't see anything indicating that at some point, we should add up all the masses. There's nothing here telling me that we should add up all the weights. Okay? There just seems to be her. Now, maybe there's a relationship here. I can't see it if there is one. There probably is one. Like, how do you go from 20 to 196? That's hard to figure out for me. How do I go from 50 to 490? How do I go for 130 and match it into there? So there's probably a ratio between the mass and the weights here. We don't know enough about this yet to be able to figure that out. Or if there was simpler numbers, we may have been able to do that. So maybe these are ugly enough numbers that the ratio is not leaping out of this yet. Okay? But what we have is a bunch of pairs of matching masses and weights. Kilograms versus newtons. I don't know. So let's see here. The table below lists 4 masses, okay, and their weights. So the first problem is weight. There's 5 things here. Well, this one doesn't list it. You could say, well, list the mass of X. It's talking about the 20, 50, 130, and 40. So that's the first thing, and their corresponding weights. The ratio of weight to mass is constant. So they are telling us something. So this means that the mass, and I'm going to call this M, to the weight, and I'm going to call this W, is constant. So I'm going to put C in quotes. So we don't know what that number is. So it's telling us that 20 divided by 196, okay, is the same number as 50 over 490. Whatever that matches into, some decimal number, is the same number. And it's the same number as 130 divided by 1274. And it's the same number as 140 divided by 1372. And if we knew what x was, x divided by 1078 is also going to be that same number. So let's say 20 over 196 was 0.2, then x over 1078 should also be 0.2. Okay? So what actually is it? Okay? So it says the ratio of the weight to the mass. And by the way, we're assuming it's mass to weight, but it actually says weight to mass. So all my fractions are upside down. So I really should have wrote 196 is to 20, right? Because that's what it's saying, the ratio. It's weight. So this is even wrong. It said it was weight to mass. That's what the constant is. So we're going to get 490 over 50, and so on for the rest of these. So this is not what they're asking us to do. Okay, they're asking us to do the upside down one. Be careful with these kind of things here. So which statement describes the ratio of weight to mass? Okay, which statement does that? And the value of x in the table. Wait, what are they talking about? So it turns out they're giving us two choices here. It says, for instance, the ratio is not for A, and then there's a semicolon and stuff. So there's two parts of this. There's A, semicolon, B. So they're asking us, and which answer is both of these true? All right? And which answer is both of these true? And by the way, we have another pattern thing here, that A and B are both dealing with 98 over 10, and C and D are dealing with 98 over 10 over 98. And then A and C are dealing with 90, and B and D are dealing with 110. Interesting, right? So let me shrink this down slightly, or do we need to? Let's see. We don't need that top part anymore. It says there's four masses and their corresponding weights. So let's try to shift this so that we can get the answers at the same time as we're seeing the rest of the page. Okay, so how can we figure this out? And by the way, that's 50, and this is 20. Okay, the way to figure it out is to take one of these and just do them. All right, and that's a 0 there too. So basically, if we took 196 and divided it by 20. But I noticed something before I do that, which is that this is divided by 10, that's divided by 10. And this one's upside down. It's 10 over 98 versus 10 over 98. So they're reciprocals. So what is going on here? So we know that it's this form. So if our denominator is 10, right? Doesn't that mean the numerator is half of that too? I divided by 2, I'm going to divide by 2, right? So 196 divided by 2 turns out to be 98. Can you please do 7th grade hardest problems? My test is tomorrow. Well, there's going to be a part 3 to this, and the 7th grade is going to be after that. So the earliest I could probably get to do any 7th grade thing is probably in 2 days. All right, I'm doing the best I can. The good news is that some of this is going to apply to your 7th grade test. So all 6th grade applies to 7th grade. Maybe not 100%, but if you can solve these problems, some of them are going to be the same. In fact, some of the problems I did earlier and also yesterday for grade 6 were the exact same problems that were in the grade 5 test with different numbers. All right, so it's still going to be applicable. Of course, it builds onto it. There's going to be more advanced stuff as well. So I understand your 7th grade test is tomorrow, but there's no way for me to possibly get to do that. In fact, if you go back to the beginning of this video, and at least once throughout, I said my head is killing me. So I'm actually going to end this video very quickly, and then I'm done. I'm done for the day. Sorry. All right. I do have other videos, if you look through my channel, that deal with grade 8 math, and I think there might even be some grade 7 ones that I did maybe a year and a half ago that you may want to search through. I reviewed some other state tests involving some math problems as well. Pretty sure it was grade 8, so that doesn't help you perfectly either, but some also may have been grade 7, okay? So hopefully that's helpful to you. So getting back to this, this means that C and D are not the answer. Okay? Because we get 98 over 10. So that's the ratio. Okay? And by the way, we could have also got that same ratio by looking at the 490 over 50. And that's a good thing to kind of double check. By the way, if you have specific questions, definitely email them to me, like 1, 2, or 3 questions. If there's something you're not sure about, email them to me, and I will definitely give you help you through the answers. All right. But I can't do another 2 hours today. I'm really sorry. But again, if you have a few questions, email me. I will absolutely completely answer them very thoroughly. All right. All right. Okay. So if we get 100 at the bottom, all we did was double that. So 490 times 2 is 980. Okay, and we doubled the bottom as well. So that's 100. And then if we cross off these 2 zeros, we also get the 98 over 10. Okay, so we have a way to confirm it. And for some of you, it may have leaped out that this was actually the faster way to get it. Just double that, and you can see that it matches the 98 over 100. So now that we got the ratio of 98 over 10, how the heck do we figure out dx? Okay, well, it means that 98 over 10 is equal to 1078 over x. So we can do a cross product stuff here. And once you do that, right, we can do 98 times x yeah, that's come out sloppy. And then do the cross product that way. Equals 1078 times 10, so I'm just going to add a 0 over there. Okay, and then if we divide both sides by the 98, this cancels out, and then we have 98 over here. So that's what this problem reduces down to, doing that division now. All right? Whoops. Is commission like tax? Yes, in some cases it can be because it's often a percent. Commission is not always percent, but yes, enough of the problems they're going to give you here is like percent, and it is like the tax. Yes. So just remember, gotcha with stuff like that is that you might deal with whether it's over 1 or less than 1. So if there's a 10% commission, you're either going to deal with 10 over 100 or 110 over 100, depending on how the question is worded. So just be careful with that. All right. So let's actually do that division. So 98 goes into 1, 0, 7, 8, 0. So 98 into 1, no. 98 into 10, no. 98 into 107, yep. So we get 98. Okay. We get 9 as the answer. We drop down to 8. So 98 goes into 98 once. And then we have no remainder, and we get 0. So that means our answer is B. Booyah! Yeah, no problem. And again, you can email me questions. Pretty much any time of the day that you want. So if you come up with a question at midnight, although you should be asleep if you're having the test tomorrow, hopefully that helps. All right, actually, how far am I into the stream? I'm about an hour, and I'm pretty much done. I'm done with. Please subscribe to the channel, by the way. Please like the video. Yeah, I think I'm going to call it a day. My head's killing me, and I'm slowing down. All right, guys. Hopefully this has been helpful. Let me double check here. We didn't get as far as I wanted to. We're still only halfway. We're not even halfway through the problems. But I'm just going to do the best I can through this. These are some of the harder problems, and they're worth spending the time going through them. I will make an attempt to get through these. There's probably going to be 2 more parts to this, but that's the way it goes. They're the harder problems, and I want to make sure you guys are getting a variety, and you're seeing my thought process through this, and how to figure it out, and the best way to do it, and how to take the problems and rip them to pieces, and then build them back up mathematically. Okay. And if you can see, I'm using what some of you might call tricks. Sub tutors and teachers. Oh, let me teach. I don't think it's a trick. It's math. It's math. I'm telling you. It's not a trick when you know that 12 times 10, you just add a 0 to the end of it, because you already learned how it worked, and you know how the math works. So that's just a shortcut at that point. So in a lot of cases, you know a lot of mathematical shortcuts. There was a point where you did 6 times 6, and you wrote it out like, if there was 6 rows of, 6 pumpkins, and you would count them. You don't need to do that anymore. You just know 6 times 6 is 36. So some of these shortcuts are the same way. The problem with shortcuts is they're not obvious to you all the time. What I'm trying to do is get you to tap yourself on the shoulder, tap your brain inside of your whatever you have in there, your synapses, and try to make logical sense out of some of this, and then jog yourself like, I have this mathematical toolkit in my head. What can I pull out of it when I need to? Even if I've never seen a problem before, even if I don't know how to solve a certain problem, what can I pull out of my brain to get me there where I need to be? All right. So with that, I'm going to exit. I hope you guys, at least in New York, do well. Again, this is not. I'm not doing these things to basically do test prep. This is not what the point of this is about. I'm just picking some problems that students often have problems with, and I'm calling them the hardest problems, and that's where we're going. And speaking of going, I'm going. Peace, everybody. Lots of love and joy in your life this week, and I hope things go well. And remember to smash that like channel now. Bye.